Okay, welcome this is actually surprisingly my first JavaScript tech talk night, and so I decided to talk on my first outing. And just wanted to thank you all for letting me talk here tonight, and Tazveer for letting me do this presentation. So, okay, well, who am I? My background is predominantly in video games, 3D graphics software, and computer animation production, so feature animation. So this is sort of like some of the highlights of where I've been and what I've done in the past. And then go to the next slide. So, why am I up here talking about WebGL? Well, so back in the day, I was working for a company that used to be called Alias Research, and I was developing on one of their core programs called Power Animator, and it was all Irix GL and C++ code, so I got to know it from the sort of like historical GL side of things. And then actually at a certain point, when I got into feature production, I actually started to do web development work, but totally internal websites and web servers. No one else could get into these. It was just all the people on a feature animated production, all the animators and production people. So it was all like asset tracking and production management tools, but it was all HTML, JavaScript. And actually back in the day, we had I don't know if you guys know Houdini, but it's a kind of a 3D visual effects software. And they had an embedded browser, and it was still a little rough around the edges, but we actually used it for production so that people could go to a web page embedded in Houdini, and it would make callbacks into Houdini and actually like load up their stuff based on the server side stuff in the production tracking information. So that was pretty cool. So it sort of combined, I know web stuff and graphic stuff. And this was pretty funny. So I don't know if you guys know, but this is, I don't know if you can see it, but South Park used to be done, still is done in 3D software, but Power Animator was like a $20,000 piece of software for one seat back in the day. And so they used to have it, and it was hilarious to watch them like move around these objects that were basically just 2D guys. And so that show was done on super expensive software. And they use Maya now, though. So yeah, just brief history. Really kind of back in the 80s, it was a different graphics library called Figs, and it was like Sun and IBM and DEC and HP. All those guys had flavors of Figs, and I remember from my university computer graphics course, we were coding in Figs and doing little object model viewers. But sort of coming into the 90s, SGI started to really do well selling their graphics workstations. And on their side, they had put together the Irix graphics library. And in the early 90s, they decided to kind of open source that library and started WebGL. And that's really where it kind of comes from. And just a note, Shrek 3D in 1995 was at that sort of late 90s era. People were definitely, if you were doing any PC games, that's what you were coding in, but all sorts of other stuff, like actually the Nintendo 64 had a Unix underbelly, and their subsystem was a GL-based subsystem, so for graphics. Yeah, and then in 2006, the Kronos Group, which is a nonprofit tech consortium, was given the reins of OpenGL to kind of spearhead moving forward that API, and it's been in good hands actually with them. And so 2007 is when the first real sort of implementations of WebGL in the browser started to happen. So. And then sort of finally, as people started to really work together to get WebGL going, we have 2009, the WebGL working group put together with Google, Apple, all the big players. So Okay, so what I'm going to do today is kind of dive in and talk about coding in kind of raw WebGL. So these days, you guys probably have heard of Three.js, and there's a whole bunch of other kind of wrappers around WebGL to give you more of a framework. WebGL, like OpenGL, is pretty low level. So, I mean, it buys you a lot because it's your hook into the hardware accelerated, 3D optimizations on all devices and machines. And, but, it doesn't provide you with all this other stuff. So I was just getting kind of back into doing some more low level, like writing some little games and stuff for myself, and started playing around with WebGL. And it was funny, I forgot how, like WebGL doesn't give you by itself any sort of hierarchical transformations or anything like that. So you have to use somebody else's library for matrix math and things like that. And I had forgotten all of the the transformation orders and stuff. So I remember the first test was like totally screwing up, and I was like, where is this thing? It's not in my screen. And so eventually I kind of plugged through it and got there. But you don't actually have to do that. If you use Three.js, they give you tons of high-level tools to automatically set up a perspective camera for you, things like that. But so if you haven't done any graphics work, I'd suggest that you dive into Three.js. But if you are interested, and I think it's a good exercise to actually write low-level WebGL code to sort of see what it's like under the hood. It gives you a really good insight into a lot of the problems that you may encounter, and I find it's always good to know that stuff. So, okay, so let's get started. Okay, let's pop this up. So this is WebGL running in a canvas element in Chrome, and so what I'm going to start to talk this talk with is just the structure and the entry points for doing WebGL. So here is, let's see, the HTML. Started. I just built this yesterday. Okay, so scroll down. Okay, so first thing that you need is canvas. So this is like HTML5 thing. So this, the canvas element is just interesting though, because you can get different contexts from it. And so you can work with a canvas using WebGL, or you can use there's Canvas 2D. There's a few other ways to be able to work with it. So for today's purposes, just be doing WebGL. So first in your HTML, you need the canvas element. And so there it is. And so let's look at the, okay, so scene start. Okay, so first off, I'm getting the canvas element, and so I have this thing where it's like, oh, initialize GL. So that is in, okay, so I didn't actually have the listing for the code that actually has it. So bear with me as, I don't even know if you're gonna be able to see this. Here we go. Let's see if we can make that bigger still. Basically, this is what you'll see, and I mean, I kind of pulled this from various examples, but all I need to do is just, with the canvas element itself, just make a call for get context. And yeah, and it's kind of funny, it's still this experimental WebGL thing. But you can do Canvas 2D as well, getting the context. And then that context gives you a bunch of stuff. So it will, here I'm setting the viewport width and the height, and then it just sort of returns back. So so that's really all there is to setting it up from that low level part. So getting back to here, I'll just get rid of that and go back here. So okay, so structure-wise, we just set the GL, and I've actually done I don't think I can't not program with objects and classes. So I created a whole bunch of classes to help me get through this. So the scene is sort of your like top level structure to manage all the elements that you want to draw and all the good stuff. And so I create a new one here and I give it the GL context so it knows how to draw and how to set things up. So, and then for me, I just kind of have these convenience things where I have separate demos actually running in the same GL canvas, and I only activate them based on clicking one of these. And then if you guys haven't ever done any sort of like looped game engine-y stuff, then you need to do sort of the setup that allows it to just kind of loop around basically this stuff. So the scene will update itself. This is where you do kind of any of your, kind of animations and stuff in terms of calculations. So if you're changing transforms and things like that, you do all that stuff in the update, and then the draw just focuses on entirely drawing what is the current state of all the things in your scene. And stats actually doesn't do anything. So I meant it for frames per second and stuff, but that'll come later. That's the basic setup. So okay, so we'll get into some of the kind of lower level stuff like shaders and how they get set up, because that's probably one of the trickier parts in getting up to speed on doing WebGL itself. 3JS has a lot of great tools to give you like material objects that you just give a bunch of parameters. Much more pleasant and makes a lot more sense. But I think this is the big thing about WebGL and OpenGL ES, all the embedded system stuff. It's now the sort of programmable like hardware shader stuff, and that's where you can start to do super cool things and get a lot of your efficiencies there. What we're going to start looking at though is, well, let's look at this. Oh, here we go, demo test. Okay, so just to kind of look at how something gets built up in terms of how I'm doing it in my little engine here. So this is so basically I created this low-level object called a sprite, but it basically from here the demo like adds it, and then the demo itself gets added to the scene. But one of the things to show you is how it's actually done. So sort of one of the more important things. So this is my sort of sprite object, and so it gets given the scene because it needs to sort of know the GL context and some other things that the scene knows about. And I also created the draw node. So this is inherits from the draw node. The draw node is the sort of like transform node and also the parenting node. So I kind of cheated. It's like I just wrapped a whole bunch of stuff into one thing. But I send in the image file right away. Kind of just wanted to get things going quickly. So basically I do some setup, and for another one of my little demos, I'll show you. This one has frames of animation, like sprite animation. So that's what some of this setup is here for. But the main part here is here. So this sprite is going to have a GL texture. So we go ahead and create one from the context, and then the GL texture has a handle to the image. So this is more the web browser image container. And here is, right, so basically I'm gonna load up that image source, but prepare it give it a function for the onload. So when it comes back, it's gonna call back this thing. So let's look at that, because that's a sort of an important one here. Handle loaded image. And sorry, I hope I'm not like scrolling back and forth too fast. Just let me know. Just shout it if it's too distracting. Okay, so here we go. So we get the GL context, and So we're basically getting passed in the GL texture. So the GL texture was set up in the initialization, but it was passed into, it has the image source that it's the browser's loading. So when this gets called, it just passes in the GL texture just so that we have that handle. Although the handle is actually part of the object. So anyway, so we have to bind the texture as a 2D texture. So this is like the first thing you need to do. And also this is interesting because if you like just load in an image, it's actually into WebGL, it's kind of upside down. So the Y is flipped. So if you want your image to go, well, 0, 0 on the bottom left of it is, yeah, well, it's just the other way. So I come from more of a background where I want 0, 0 of the texture coordinate to be at the bottom left. So I actually flip it so it's, it draws upwards. So that Y is up. And mostly to match my coordinate system. So I have like Y up, X going to the right in terms of positive values. The other thing to also watch out for is PNGs get handled kind of differently. So this is sort of something to do in your setup as well. There's a bunch of this stuff. I'm also going to try to package up this stuff and get it out on GitHub or someplace. I haven't had a chance to do it yet, so bear with me. I'll tweet to @TorontoJS when I've had the chance to put it together. But but if you look at a lot of the WebGL examples out there, there's you'll find this. There's a website called learningwebgl.com, I think, and that has a whole bunch of lessons and great examples. So so that's another thing to watch out for. The other big thing to watch out for is your textures have to have a resolution. The resolution has to be in powers of 2. So your X resolution, your Y resolution, each of them has to be, like 2, 4, 16, 256, 512, 1024. Otherwise, they don't show up. They don't render. So that's one of the things that's a little trickier. Some of the frameworks that you can use in terms of using OpenGL or WebGL will handle that under the hood for you. So they'll either stretch it to the next power of 2 or can break it up. Sometimes I actually did in a prototype that I'll show you. I'll just show you a demo of it. But I actually was able to take any size image and I don't do it on the JavaScript side, but I do a post-process or a pre-process on the images to break them up into power of 2 bits. That was more of an efficiency thing. So, and also just a little experiment to figure that out. So, okay, so this is setting up your texture. I really should have had a mode where this was like expanded. Sorry, guys. So yeah, so this is, oh, sorry, we're down here. So this text image 2D, it's more of the setup, and I'm basically saying that it's going to be a texture with RGB values plus an alpha. So, and if you do any sort of game stuff or a lot of image processing, that's usually what you want to do. So, and yeah, and you actually pass in the texture image itself, or the image of the GL texture. And this stuff here, I kind of don't have it set up for MIP mapping, but if you guys are familiar with MIP mapping, which is, that the system under the hood will actually generate like these, what they call MIP maps. And so it's like different versions of the texture at lower reses. So that you won't get the sparkling if you're kind of zooming in. It's mostly for like if you're actually doing real 3D stuff in a scene, then I don't know if you've played games where it's like, where you're getting like different angles or different closeness to certain objects and the textures start sparkling, like it's kind of all over the place. So those aren't MIP mapped. So you can set up MIP mapping here. Usually if you're gonna do more of a 3D game, then that's the case. For me, I'm coming to WebGL to actually do more 2D stuff. So as a bit of more on the background for me is I'm working on more digital storytelling stuff. So it's more images and text and stuff, like 2D stuff. So, okay, so that's all the setup here. And you bind the texture to null just to sort of kind of clear things out so that the bind doesn't have the handle to that texture still. Okay, and so, okay, and now here in the util, my little util object, I have different things to kind of do all the work for actually generating the vertex buffers. So, so we've loaded the image that's going to be used as the texture, but now you need geometry to map it to. So that's the whole thing with like OpenGL and WebGL is, you know, it's 3D. So you need geometry, a mesh, and then a texture to apply to it. They do have some other primitives, but mostly this is how you'll work. So we'll close this one and go down to util, which I do have here. Okay, so create vertex buffers. Let's get to a simpler one. Okay, so here is kind of a function I have to create the geometry based on the size of the texture. So it's just gonna, basically the canvas there is 800 by 800 pixels, and I'm kind of mapping like a point in geometry space to a kind of pixel space. So if you have, you know, a vertex at 1010, it's gonna be here at like the 10th, or well, 11th, I guess, if you're counting 0. So it gets passed in here, and the object is, so I have a few different things that kinds of, I have a sprite object, a text sprite object, which I'm going to talk a little bit about in a bit. So the text that's scrolling up there is actually, it's text that was drawn to a 2D canvas using sort of a dynamically just created and thrown away canvas element, and then we generate a texture from that. So I'll talk about that in a little bit. But so anyways, so I have a few different objects. So this is like the base sprite object that's coming in, and it's getting passed in the GL context, and it's the GL texture that you want to kind of map it against to, or against. So basically you take, I'm taking the width and the height of the actual image, and I'm storing that because I'm gonna actually put the vertices at those points. Now, one of the things that I'm doing also is, and I just find it easier in terms of positioning things, to put, I'm capturing the half width and the half height because I actually put the pivot of the object in the middle of it, in the middle of the texture. So, so if I put this, this image at like X, Y, 0, 0, like you only see like the top left-hand corner of this thing. So, and that's really just like if you have rotations, it's sort of easier, it makes more sense to me to be rotating it around the center and stuff. So, and it's easier to manage. So that's what this is for. And then, so you have to first, okay, and this is the geometry setup. So set up the kind of vertex list, and this is the actual positions in space. So this is the 3D geometry like structure and positions. So that's what this is. And WebGL is 3D, so, but everything is at 0. And I don't think I'm using the depth buffer, but the reason things will just show up in front of another thing is just draw order. So a lot of 2D applications just, you know, avoid the sort of overhead of depth buffer calculations just because if the needs are simple, which my needs are, you can just, you know, maintain a draw order, and in your application that can manage the order of the actual objects that get drawn to the scene. So, so that's why it doesn't really matter that they're all at Z equals 0. Okay, so that's the vertex position. So from the GL context, we create a buffer. So there's a few different vertex buffers that we're generating. The first is the position one. So that's what's being done here. And this is just the setup. So in the buffer, we know that it's 3 coordinates for each position. So that's what this is. And then the number of items based on all of that. So, and then I'm actually in the object, I'm maintaining a handle to this. So the object actually gets this buffer as a handle, and that's important later on in the draw. So you'll need to sort of keep all these buffers handy for each object. Okay, the next one is the texture coordinate buffer. So the texture coordinates are basically where how the texture maps onto your geometry. So, for example, the way this is working is that it's putting the vertices actually at each of the corners of the image. So you're just basically displaying the image. But and I'll show you a bit later. But you can, your texture coordinates could map in very different ways. So this texture could look all skewed. The physical geometry will still be this sort of rectangle, but the texture you can actually move it around by modifying the what they call the texture coordinates at each corner, because it's actually where the position in the image that you start sort of mapping from and pulling the pixels from. So so the texture coordinates are really important, especially if you get into a lot of game stuff, because your sprite sheets are one image with a whole bunch of things on it. So your little pieces of geometry, need to map to only one small piece of that sprite sheet. So that's sort of an important factor. And here's the setup. So basically, these are the coordinates. So texture coordinates go from 0 to 1. So 0, 0 is the bottom left-hand corner of the image to the top right, 1, 1. But again, remember that I did that thing where I kind of flipped the image in Y, because when WebGL reads it in, I think by default it's actually upside down in terms of working this way. This is sort of a common way to work in terms of graphics in various places. So, so we set that up, and again, here though, it's only each texture coordinate is only two items, because it's just the sort of position along X in the texture and the position along Y in the texture. And they actually, in computer graphics, it's more commonly called S and T and U and V. So there's tools out there called UV tools, and people doing 3D graphics use those things a lot. So, okay, and the last thing is, this is the vertex index list. So what you've set up is like data for each vertex that's in, so basically it's just the 4 corners of this rectangle. But what you don't see is, and I should have had a mode to turn on wireframe, but there's actually 2 triangles here. So, it looks like this. So there's actually 2 triangles that have to map to those 4 vertices. So, and OpenGL and GL is a triangle-based engine, so everything gets triangulated in order to draw. So this is what this is. So this vertex list maps each polygon to a set of 3 position coordinates and a set of 3 texture coordinates. So, and you can juggle those around, which makes it interesting when you're mapping things in a game. Okay, so this is all the setup. So we, again, in the target object, this is the sprite. So we're storing the vertex index buffer, and we already got the texture coordinate buffer and the vertex position buffer. So that's the setup there. So this is sort of the setup you have to do for sort of each thing that you bring in. So there's sort of a lot of code here, but again, if you use something like Three.js, they have these utilities that just do all that for you. So, I mean, for me, it was good because I really started to understand, again, it had been sort of a long time since I'd done sort of this low level of graphics work. A lot of the tools in that I worked on in the games industry and in the feature animation where, a lot of stuff had been built and I just built tools on top of them. So I didn't have to do anything low level there. So, okay, so that's the setup for actually being able to get this on screen to draw. So one of the things that has to be set up for WebGL is shaders. So I had mentioned it earlier, so this is sort of setting up the object itself and the information that the sort of renderer needs to use to draw it. But each of these objects will need a vertex shader and a fragment shader. So those are the two shaders that need to be set up. And I just sort of have a default one that's used by like all the objects. And the shader that I've set up gives me the ability for these images to be color tinted, so RGB tinting, and also transparency, so alpha blending. So those are the main things. I kept it super simple, but like a lot of the cool effects like bump mapping and things like that are done in shader. So I don't have any super complex examples of those to show you from my stuff. But okay, let's close this guy down and get back to the HTML because I stuck the shader code in here. So, okay, so let's have a look at the shaders. So this is the vertex shader. So basically this bit of code gets called at each vertex. So the thing you can do with the vertex shader is you can actually move the geometry. So your object is always stored sort of in fixed positions, but the shader itself can put like a noise or like a sine wave or something to apply to the actual positions of the vertices. So when it draws on the screen, it can be impacted by whatever code you write in this little bit of code that runs kind of in hardware. So the things you can adjust are, I think you can adjust texture coordinates, you can adjust the actual positions of the vertices, but this is more about the geometry and how it's mapped. The actual affecting of the pixels on the screen comes from the fragment shader. So this is earlier in the rendering pipeline for OpenGL, but this is sort of an important piece. You can do a lot of interesting stuff here, but I've kept it very simple. And so basically it is, and so another sort of low-level thing is that the shader gets passed in. This is the projection matrix, which is the 4x4 matrix that is generated based on the information about your camera and your position of the camera, what the camera is looking at. So that's, and your viewport and all those things affect that matrix. And then this is what they call the model view matrix. And that's affected by the transformations that you're doing, like rotations to the object, translations, and scaling on the object itself, and also if it's parented. So if its parent is scaled and bigger, then it will also get scaled bigger. And this is just passing along the texture coordinate. So I'm not doing anything. I could actually affect the texture coordinate here and do crazy stuff with it, but I'm just leaving it alone. Okay, the next thing is the fragment shader. So once the sort of geometry is set in position and texture coordinates, we start to get into the pipeline that's actually grabbing, figuring out the pixels that need to be drawn, and also like what information is coming into being able to draw that pixel and what color it's going to be. So it's not really on here. I'm not doing any complex lighting or anything like that, but this is where you'd handle a lot of stuff. So for example, if you guys have seen, like the basic graphics shaders, like the Phong shader, the blend shader, all those ones, they have different attributes like specular, like how much light is reflecting like off this part of my mouse. So so those kinds of computations can be affected, here. What I'm doing is pretty simple. So what I'm passing through is alpha and RGB that I'm storing for each object. So And I'm not touching the texture coordinates. So getting this information from the object that's getting passed in, I'm taking this sampler here just grabs the sort of texture from the assigned image based on the texture coordinates that are coming in from that point on your polygon. And then this is the actual color that goes out. So I'm just taking that and multiplying it by the R, G, and B values that I've passed in for the color tinting. And then the final thing is the alpha as well. So, yeah?
Are those variable names magical?
Okay, well, that's what I'm going to get into. This is, they seem magical, and it was tricky to get back into it because my experience with GL before, like, I was pre sort of hardware shaders. So, you know, all this, my approach to GL was very different from what it needs to be now. So, and I stumbled a lot in terms of like figuring out how these things mapped, and I'll go through that. And unfortunately, I don't have this thing very wide, but if you can bear with me, I'll point you to the right thing. So, yeah, so there's actually a few things here. Okay, so for a shader, there's things called attributes, and there's things called uniforms. Those are some pretty important ones. There's a few other things, but I'll just keep it a little bit simple now. So the attributes are things that are actually coming from the drawing and rendering of the engine. So based on the stuff that we set up for the object itself, like that vertex list of positions and the vertex list of texture coordinates. So it gets, those buffers get mapped to these attributes. So they're sort of low-level setup things that are usually always there. So those are attributes. You can do custom attributes, but it's kind of tricky. And I won't get into that today. But the uniforms are the things that you can pass in from your JavaScript code. So, and you have to set it up to be able to do that, and I will show you that. So, and that's how actually I was able to do this. So from the object itself, each of my sprites in their little object, they store their alpha, they store their RGBs, and when a sprite goes to draw itself, it sets that up and puts it into the GL context in a way that this shader is going to get that information. So that's what the uniforms are for. So you can do like floats, ints, you can do vectors, vector 2, vector 3 of different values. So I don't have the example here, but like for example, I passed in the time. So you could actually pass in time to your vertex shader, and based on the time, you know, do some crazy modification to their positions. So those are the kinds of things you can do. So we'll keep this shader code here and get back to the scene setup, I believe is where. This is part of what the scene does when it first gets created. So there's only one scene in all this code here, and it gets initialized and all this stuff gets created just once at the beginning. So this is the default shader program. So I mentioned that there's a vertex shader code and fragment shader code, but all that gets pulled into a single, what they call a shader program, and compiled into a shader program. So here, this is the scene, grabbing its GL context, and this code here, is just getting the actual text that's in the shader code. So this fragment shader and vertex shader is actually just the text that's in those script DOM elements. And so here we take the GL context and we create a program. So we keep, yeah?
It's not a GLFS default. What's that about?
Oh, sorry. No, it's just, so it's my default shaders, and this is like a GL fragment shader and a GL vertex shader. So they're actually better named in other people's code. So like, they'll usually be called like fragment shader and vertex shader. But those are the things that we just were looking at. See how this was script ID, GLFS default, and GLVS default. And yes, I should name them better. So that's where it's getting. It's getting it from the HTML code that has it embedded in its couple of script DOM elements. Okay, so we create a new program, so we get the handle to that. And so the scene is going to hang on to this. And so this code, so we attach the shader code and for the vertex and the fragment shading, and then we link the program. So this basically says, okay, I've kind of done the setup for the program, and now we have to like actually hook it up to the renderer so that the renderer knows about it. And this is just a way to figure out if it worked or not. So, and you'll see this in a lot of like low-level code if you're not using 3JS or something. And then this is saying for GL to use the program. So I don't know if actually. Yeah, so we set up GL to be thinking about this, this particular shader with this call, and then we have to set up various shader attributes. This stuff is doing let's just slide this over. Okay, so here's the key. So the shaders, if you noticed, these were the things that showed up in the shader code. So these are the names here. So this is the magic. So, and to really know what you're doing the setup for, I mean, I didn't write this code from scratch. I pulled it from somewhere, and this code is in a lot of programs out there on the web. So it's basically the same way to do the setup, but and it's the way to know how to sort of add something new. So I mean, these are the basic things. So like the attributes are like the position and the texture coordinates. So that's why they're attributes. These uniforms though are like all the stuff that so the uniforms happen across all the vertices of your object. So that's kind of why they say they're uniform. So they'll have the same value across all the vertices for that object. So, but this is where we pass in the matrix stuff. And this is where, I did pass in the scene time, I just don't actually use it. Okay, so, and I was trying something interesting. So I didn't use these, but I was passing in the scene time and then some value to try to do some warping, but I didn't quite get there. But this is the stuff that is relevant and working here, is that the RGB and the alpha is stuff that is working. So and this just needs to get set up once. So, and it gets more, like you can have more than one shader. This is just one shader, a default shader, I use it for everything there. So that's that piece. And again, this is where all that stuff shows up. So these names here have to match up to the actual variable names in your shader code. So the next important place to go is, I think the sprite draw self. Here, draw GL texture. Okay, so, this is kind of where the rest of the magic happens. So I'll skip this sort of more complicated stuff, but basically for this single sprite here, we've got the different buffers. So I just sort of grab a local variable, handle them to make things easier. And these are the things that happen. So, okay, so here's basically the setup. So, and this GL shader program is that default shader. So I've got that in that handle. And basically you have to set up this was the name on the shader that matches to the attribute vertex buffer. So kind of, you have to look at these things together to kind of find out where they match. But basically this is setting up the attribute for the vertex positions, and this one is the attribute for the texture coordinates. And then there's one last thing, which is the vertex index buffer, which is basically which vertices go with which triangles. And then we're activating the texture, and we bind the the GL texture that's mapped to this sprite. So that's how it knows how to draw this particular texture versus this one. So, okay, so then it goes down through, and I actually have a hierarchical setup. So basically it goes through and you can have alpha sort of up and down the chain and also other things. But this is where it grabs the uniforms and sets them up. So gl.uniform1f, and that's the alpha. And I could have done this in a vector, but I think I just needed to make sure it worked. So I passed them in separately for RG and B. And actually, just so you can see it, which one is it? Nope. Oh, you know what? Oh, I totally didn't. Anyways, this is another one. This is actually where the texture coordinates are changing to map to the sprite sheet. So, but anyways, I actually didn't hook up my other demo, which actually shows the color tinting. But anyways, so that's some of the key places. So the shader code, the setup of the shader for the scene, and then in the actual draw, you have to sort of like set up the information that's going to go to the shader. So those are the kind of 3 key areas in terms of the render pipeline. And yeah, sort of going back to this one is, the sprite actually has the ability to do, to have sort of multiple images on a sheet, and you can just sort of specify in the setup, and it basically is doing a turntable of this guy. So, and that's just changing texture coordinates. So it's basically drawing an imaginary square here and just moving it over each time. So that's how texture coordinates work. And you'll see that in even maps and stuff. They'll have tiles for different things, and you can repeat the tiles in different things, but it's one sheet of all the stuff. Okay, I think before, the last thing I'll do then, just for, I think it's maybe valuable, is show you this, and then I didn't realize we had run so long. So this is, let's see. Okay, so this is how you do text in GL, or one way to do it, I guess. Probably the most direct way to do it. You can do like 3D text or text in geometry, but this is basically taking a canvas element, but getting a 2D context to it, and using canvas 2D stuff to actually write the text to the canvas image. And then, and here's just sort of making sure that it's a power of 2 canvas image, because that's what the texture needs to be for WebGL. And then, yeah, so then we sort of set up all the text writing attributes for the canvas 2D, write it to the canvas, write the text to the canvas. And then, once that's done, we grab the GL context again, create a GL texture. This time the image for the GL texture is actually the canvas element. And then we do a lot of the similar stuff. We bind it, we flip the Y, and then we do all the similar setup, like it's an RGBA texture. I was playing around with mip mapping. That sort of doesn't do anything right now. And then we just sort of clean up the setup, and then we generate vertex buffers from it. So if you are trying to get text into your WebGL app, then this is a way to do it. So just you can Google like Canvas 2D WebGL and fonts or text, and you'll be able to get that. So okay, so that's, I mean, mostly, I actually had another little demo to show, but I actually hooked these up to the same thing, so sad. But are there any questions? Yeah, I had more stuff to get into and some examples, but I think we're kind of running out of time, so. But yeah, this is, again, this is all like WebGL, so this is all low level, like there's nothing used here except for like a matrix library and then a whole bunch of libraries that I just created for this stuff. But definitely look into 3JS. 3JS is really big now. And actually, let me just show you. So, there's some cool stuff here, like normal mode. And if you come from like 3D stuff, this is pretty cool. This is actually pretty cool. So I always found texture mapping hard to explain, but this is sort of mapping, and it's got this sort of different colored checkerboard to show how things are actually mapping. For people who do this work, these kinds of tools are pretty awesome, and this just blows me away that this is happening in like a web browser. But even cooler is, oh no, wait, I think it's this. Oh, I should put it maybe back in its lit rendered mode. Yeah, the offset's a little nuts. I tried my little glasses, and I think it's a little too extreme. I'm not sure exactly what but you know, they're doing this on a web browser. It's kind of crazy. So, yeah, so there's a lot of cool stuff that's happening out there, WebGL in the wild. So things like this is pretty impressive. This is a commercial, practical application. There's tons of demos out there. I'll blog a list of stuff and tweet to @TorontoJS so you guys can see more stuff. But anyways, I hope that was informative. I hope it wasn't like too deep of a dive. I don't know. It's sort of hard to tell. It's tricky because there's a lot of just graphic stuff that's sort of needed also, graphics knowledge. But so this is my blog, and it's been under a little bit of neglect. But if you just go to mylifeatruntime.com, no spaces, that will get you there. And I'm also on Twitter, and at MacBlurb